So let's talk about correlating your IBIS model. Now most IBIS models are actually generated from SPICE models. So ideally, you'd like to get the SPICE model waveforms into a certain test load from your IC vendor. That way, you can take your IBIS model, and no matter what tool you're using to simulate it with, you can simulate it into the same test load and overlay the waveforms and look at the correlation. Now a question I get asked a lot is, well, once I overlay those, what types of metrics should I use, or what should I look at to see if my IBIS model is good or not? Now I'll tell you what I like to use. I like to use 5 metrics, okay? And so I like to look at the output voltage low, the output voltage high, the rising edge rate, the falling edge rate, and then the duty cycle, okay? And I'm going to tell you why I like to look at those things. Now looking at the output high and output low is important because that's an easy way to look at some common IBIS modeling errors, and one of them is the AC-DC mismatch. But basically what happens is if your IV and your VT data that's within your IBIS model aren't lined up right, or if they're not taking over the right ranges, what you'll see is these mismatches, and oftentimes it's these DC level mismatches on output high and output low. So what I'm talking about here is if you've got a 3.3 volt IO and it should switch from 0 volts to 3.3 volts, you might see your IBIS model, a little bit lower. It might be 100 millivolts or 200 millivolts less, than the 3.3 volt rail, where the SPICE model goes all the way up to the rail. And then that's a common IBIS modeling issue, and that's something that you would have to go back to your IC vendor and explain to them and ask them to fix. So that's one of the reasons why I like to look at the output high and low, okay? Now the edge rates, the falling and the rising, now those are important to look at just from the aspect that, you want your IBIS model to actually line up with your SPICE model and line up what the edge rate should be. So for example, if you've got a very fast edge rate of this IO buffer and it's supposed to be 50 picoseconds, you want your IBIS model to be, within a certain range of that 50 picoseconds. Now I use 10% as my guideline. If the IBIS model simulating the test load and I look at these metrics is within 10%, I say that's a good model. You're never going to get it to be exactly on, okay? So within 10% I think is more than acceptable for simulation quality. Now the last piece is the duty cycle. And this is important, right? Because you want your duty cycle to match up, because that'll affect your delays, it could affect your jitter, okay? And one issue I see some people do when they do the correlation is they'll just do a rising or falling edge. So you just do, low to high transition or a high to low transition. The problem with just using something like that for your correlation is, again, you're not going to see if there's actually a duty cycle mismatch error. So you're not ensuring that, your IBIS model has the right duty cycle. So really the way I like to do it is I like to do at least a couple of switching edges, just like a simple pulse. It doesn't have to be an advanced PRBS or anything like that. You just want to see your IBIS model switch a couple edges to make sure that, A, the IBIS model quality is good, make sure that the tool is going to read your model properly, and again, look at these 5 metrics. Now again, the metrics I like to use are the high and low voltage outputs, the rising falling edge rates, and the duty cycle. So if you put all that together, you're pretty much going to guarantee that you've got pretty good correlation of your IBIS model. Thanks for joining me today for this coffee break video. I hope you enjoyed it. If you have any questions or feedback, or if you have a topic that you'd like me to discuss next time, send me an email at tim@signalbytestech.com, and be sure to join us online at signalbytestech.com. Sign up for our newsletter, be notified of when we do another one of these videos. Now, I'm going to have another cup of coffee, and it's probably time for you to get back to work. I'll see you next time.